Okay, so this project is for EECS 2210, and our group members are Ariba, Anaga, Norin, and Sarah, and we decided to do the clap on, clap off switch circuit. We started with taking a bunch of components. So we started with a battery between 5 to 9 volts, but we used a 7-volt battery. We used a condenser mic, 4 types of resistor ranging from 1K to 100K, an NPN transistor with specifically the BC547, a capacitor of 10 microfarads, LED breadboard wires, and IC7474, or more precisely, the DM74 S74ND type flip-flop. And we'll be explaining how the clap-on, clap-off switch circuit works. The circuit uses sound as a trigger to turn on an LED, so it turns the LED on or off, showcasing how everyday sounds can control electronic devices, and we're going to break it down step by step.
So initially the circuit is in a stable state, which means that the transistor remains off because there's not enough voltage across the base emitter junction, which is right here. As a result, point A is at a high potential since point A is connected to the trigger pin, pin 2, of the 555 timer IC. This pin also is at a high voltage. For the 555 timer to activate, the trigger pin voltage must drop below a third of the supply voltage. So that means VCC divided by 3. In this initial state, that doesn't happen. So consequently, there's no output from the timer, no clock pulse for the D-type flip-flop, and so the LED stays off.
When you clap near the condenser microphone, it converts the sound into a small electrical signal. This signal raises the voltage at the base of the transistor, switching it on. Once the transistor turns on, point A drops to a low potential. This triggers the 555 IC timer because its trigger pin voltage also falls below VCC over 3. The 555 IC timer then produces a high output at pin 3.
The clock pulse from the 555 timer is sent to the D-type flip-flop. The flip-flop toggles its state with each pulse. If the LED was off, the flip-flop sets it to on by activating pin Q, which is in our case here, pin 5. Pin Q is connected to a 1 kilo ohm resistor, as you can see, which is in series with the LED. This resistor limits the current flowing to the LED, ensuring it lights up without damage. The LED will stay on until the next clock pulse, triggered by another clap. The 555 timer operates in monostable mode, meaning its output pulse lasts for a duration determined by resistor R1 and capacitor C1. This configuration ensures that the circuit is responsive and stable. Now let's show you a quick demo of how our project behaves.